Hey, Vlad here, devinside.com. Welcome to another video. In the previous video, we implemented a function called fold, which is pretty much the father of all recursive traversals. And I wanted to make this video about variance, but then I realized that we're lacking a few missing pieces. So we're going to implement a few extra functions, like for example, toString today. And also, we shouldn't forget that sets are functions. As always, we are in the Ubuntu virtual machine and we have Sublime at the top and the regular terminal at the bottom, which runs SBT, which runs our test for us. So we're going to start this video by realizing that every set is actually a function, but we don't actually have a test for that. So if I comment this out, right, and this obviously doesn't override anything anymore, then our tests, they still should be green. And for some reason, it takes some time to compile because this apparently changes a lot. But in just a few seconds, we should see that the tests are still green. There we go. All right, so we're going to start today with writing a test. We haven't done this in the previous video. And the test is going to be called set should be a function. Set should be a function. I'm not sure why I'm spelling this with capital S and F, but whatever. So what we're going to do is we're going to have an ordered classmates variable, which is going to be set to a sequence. It's not a set. Right, it's not a set, it's a sequence that is coming from the Scala collections library, so we haven't implemented sequences yet, right? But they're, pretty much the same. It just said that, sets, they don't have duplicates and they don't have an order. Sequences, they can have duplicates and they do have an order, right? So that's why we're going to call this ordered classmates. And we're going to call, we're going to have a few classmates. We're going to have Alice, Bob, and we're going to have Frank. Okay, right, so what we want to do now is we want to take those ordered classmates, right? And we want to call filter. And filter does basically the same as our intersect function. So if you look at our intersect function, it basically is going to keep only the things that are not contained in the other set. But filter actually wants a function that just takes, in this case, a string and produces a boolean, right? So we want to give it a function that is going to be called isFriend like this, right? And we're going to implement it over here. Right, so we're going to have def isFriend, which is going to be a function that takes a potential friend, right, which is a string, and produces a boolean. Now we're going to implement it in just a few seconds. I just want to finish writing this test, right? So if we have the ordered classmates and we filter them by friends, right, then we should get back an ordered sequence of friends, right? So this is going to be called who should be our friend? Let's say our friends are Bob and Frank. Let's do Bob first and then Frank. Right, and just because we can in this function, we're gonna revert them, right? So how we're gonna implement this function? Well, it's a simple boolean, right? So we're just gonna say either potential friend is, let's do Frank now first, is Frank or, and we're gonna go here, say that again, potential friend equals Bob, right? So in this case, the task will obviously pass, right? What's happening? Oh yeah, should be. Sometimes I forget to do that. Should be. There we go. Okay, so notice that scalar form sort of ruined these two lines. What you can do is you can just have a comment like this, format colon off, and over here you want to make sure that you turn it back on, and then between these, so basically between over here and between over here, it's not gonna format anything, right? So it's just gonna pretty much ignore the formatting, right? And sometimes you end up making a mistake over here, right? And then it actually is gonna ruin it for you again. Right, see, so now it ruined it. So let's revert it like that. All right, so isFriend. So as you can see, we're passing a method to a function called filter. So filter is a high order function, and it wants a function that takes a string, produces a boolean, and we're using add expansion to convert the def into a function, right? So it turns out that what you can also do is that you can have a val called friends, right? And you can just create a set of all your friends. So let's do Frank and Bob, right? Frank and Bob. Right, and now what you can do is you can say ordered classmates, filter friends, right? And it should be exactly the same thing, sequence of Bob, and Frank, right? And in fact, because they're the same, then we're gonna do this. Ordered classmates filter isFriend should be, in fact, let me make some space here, like that. It should be the same as this thing, right? That thing, right? Exactly the same thing. Why? Because sets are functions. So now I commented this out, right? The extends part, I commented it out. If we go over here, I commented it out, and that's why it says, okay, I found a set of strings, but I wanted a function from string to boolean, right? So for now, what we can do is where we say here, okay, friends, we can just straight go to the apply function, right? So we're taking the function out, but we don't want to do that. In fact, so if I return that, right, compile again, and I comment this back in, and we technically don't need this override, but I just prefer to have it, right? So now it's gonna work, right? Because sets are functions. Now, why is this important? Well, it's important for simple convenience, right? So this is like way shorter than this. In fact, like it's so short that we could actually inline that over here. And in fact, I sometimes tend to call my sets like I would call this method, right? So I would actually call this set is friend sometimes. I'm not sure if this is a popular convention, but so far nobody complained. All right, so what we're gonna do now is we're gonna sort of look at our code a little bit and find out places like this that could sort of benefit from this subtype polymorphism, right? So let's see what we can scavenge, so to say. And the first thing is, we're doing filter on the sequence, but our own sets, they actually don't have a filter. They do have an intersect, but I don't have a filter. So let's just implement a filter. We're not gonna go like too crazy with tests today. But still, so if we're gonna go to intersect, and let's say that we want to have a filter over here, right? So filter is gonna look pretty much the same, but instead of set of an element over here, it's going to take the predicate, which is going to take an element and produce a boolean, right? Which is the same thing as over here, right? Element to boolean. So this is basically the same thing. I just said we're going to call it predicate. Every function that returns a boolean is called a predicate. Okay, and what it will do actually exactly the same thing. So we can just copy that, right? So as long as it compiles, then it actually does the same thing. It just doesn't compile because I call it predicate like this, right? Now it turns out that we can actually implement intersect in terms of filter, and then we get our test basically for free. Okay, so over here, all we need to do is we need to call filter. Was that right? Because remember, the set is a function, right? So in fact, why bother constraining the intersection to get a set over here? Why don't we just do the same thing and just use this function over here, right? Technically, we should be like adding tests for that, right? So we should be adding a test that explicitly states that we should be allowed to pass like any function, it takes an element and produce a boolean to intersect. So in fact, we're gonna do just because we're good Boy Scouts, we're gonna go to one of the tests to intersection, and we're just gonna add like a teeny bit of code in there, just so that it looks like we tried. Okay, so there we go, this one, the empty one. So it's not actually going to test anything, it's just going to make sure that things compile. Okay, so over here we're calling intersection with set.empty. So all we need to do is I'm just going to duplicate the line, and I'm going to say over here, an empty set is a function that takes an element and produces a false. Now, for reasons that we're going to talk about in the next video, we actually need to help out the compiler a little bit, and we need to tell it that this thing is actually, something. In this case, we don't really care what it is, but we just still need to tell the compiler what it is. In fact, I believe maybe we can say nothing here. Nothing, because I believe this is also the default type that is being inferred in this case, for example, right? All right, so let's also do a filter thing over here. Actually, let me just copy that, paste it over here to filter. Right. Now, this sort of doesn't really prove that it's actually working, but see, we turn like one line into four. Over here, we have 4 lines. So if I were to continue doing that, we would end up with like 16 lines. And I don't want to like spend time like abstracting this away. But usually, if this was a production code base, I would actually do that. But this is for educational purposes. So what we're gonna do now is we're just gonna again look through our code base and see if we can do the same thing for the others. For example, union over here, it can't take a predicate, right? So if I do this. If I put that over here, it's not going to compile because we're actually calling add, and add is not defined on the function, right? So value add is not a function. It's not a member of the function that takes an element and produces a boolean, right? So we can't do it over here, but we can actually do this in difference, right? So over here, difference that predicate, because remember that difference and filter and intersection, they're basically doing the same thing. It's just that in difference the boolean is swapped, the condition is swapped. Okay, so let's see, is subset off. Okay, so it looks like we're only calling apply over here, so it should work as well. So let's just go do this, and technically we don't need to rename this variable, but let's just do it predicate. Okay, same thing. Okay, is superset off the same as for union? You know, we're calling is subset off on that, so we can't just put a function over here, right? We need something that has the function called is subset off, the method called is subset off, and is subset off is not defined in a function. Let's see what else. We're basically looking for something that takes in a set as a parameter. Okay, it seems like there's nothing else. Okay, now since we're going through our sets and we're sort of generalizing them a little bit, you know, we had intersection, but now we sort of generalize it to a filter. Let's see what else we can generalize. So it turns out, you know, we are a function 1, which takes an element and produces a boolean. But you know, regular collections, they have a method called contains, which is basically doing the same thing. So if we were trying to implement this, it would do the same thing, right? So if I just copy that, right, and I add contains over here, just gonna call it contains. It's just a function name, right? So then apply can call contains, and now we sort of have it for free, and we have all the tests also for free. What's happening? Missing the argument from the contain thread set unapplied, blah blah blah. Set line 7. What did it do? Oh yeah, I forgot to actually pass in the input. There we go. All right, so now it's actually the same thing. What is happening? Method contains overrides nothing. Oh yeah, it doesn't actually override anything. That is correct. There we go. Okay, so we get sort of the test for free, but let's still, you know, write one test for contains, you know, for good measure. Let's just go down at the very bottom over here. Let's go here. We say set contains on an empty set should yield false. Again, like this is not, you know, these are not going to be complete tests, but because I know that everything that go through apply and ends up going through contains, you know, we have this code covered. So we're going to have set.empty contains random string should be false, and set.empty does not contain, which is, you know, which we're sort of getting for free, random string should be true, right? And I sort of forgot to add does not contain, and it's going to look pretty much the same. It's just going to be called does not contain, right? And it's just going to do, just going to call contains like this, right? And just going to say not. Okay, this is sort of like a convention. Like every time you have like a function that produces, you know, a boolean, you know, also swap it. It's going to make like functional style a bit better. When you're starting like passing functions around, it's better not to use the, you know, the it's easier not if you don't have to use the bang symbol. All right, so the next function that we're going to implement is going to be called exists, right? And exists is going to be it's going to help out with apply and with contains. So the function called exists is a high order function, and it's sort of like a filter, but it just returns a boolean if it finds something. Okay, so we're going to have exists on an empty set should yield false over here like that, and we're going to have set of empty, and we need to help the compiler out a little bit, right? Because again, high order functions, and there is a reason why it needs this type annotation. I'm going to talk about this in the next video. We're going to talk about variants, right? So set an empty string does not exist. Same thing as before. You know, not ideal test, but whatever. False should be true. So we're just going to duplicate that, bring it down a little bit like this. Now it's going to be called does not exist, and it's going to take a predicate over here. Instead of the input, it's going to take the predicate takes the element, produces a boolean, right? So you could also pass in a set over here if you wanted to, right? So does not exist, it's just going to call not exists, pass in the predicate, right? So now we can clone that like this. Exists, and exists is just going to use fold. It's going to start as a seed, you know, with false. It's going to say underscore or predicate, right? Like this. So right now everything should compile unless I made a mistake, right? So it compiles, and we're going to add a few tests for exist, but also we need to realize that, you know, apply and contains is basically doing exactly the same thing. See over here, this is basically the predicate, right? So what we can do is we can just call exist instead. So I'm just going to duplicate this line, and I'm going to comment that out. So instead, contains is basically just exists, right? And the predicate is going to be this, right? It's exactly the same code, right? So we're passing the predicate over there, right? So our code gets like a little bit more general, which is what this video about, which is what this video is about. So let's add the other test for contains, which is going to be like this: exists on a non-empty set should yield true. This is also one of the reasons why raw code coverage is actually not that much useful, because you sort of get code coverage for free if you refactor your code, but you sometimes also should have explicit tests. And this is also one of the reasons why people tend not to write so many tests, because of this combinatorial complexity that arises. So you end up needing writing exponentially more tests. And this is also where test frameworks like Scala Check that generate tests for you are so useful. And in the future, I'm sure I'm going to make a proper video about Scala Check. In fact, there is an entire book about Scala Check, which is crazy. Anyway, let's get going. So we're going to have an element over here, which is just going to be a random string. And what we're going to do is, let me scroll down a little bit. We're just going to create a set of this element. And we're going to say it exists. And let's just do size, because it's a string. Remember, the size of the string should be the same as element.size, right? So this is a tautology. This should always be true. And we're just going to duplicate that. And we're going to say not over here. And this one should be false. And let's also do this over here and say does not exist, and that should be false, and does not exist of that should be true, which all makes sense. I hope it's green. It's green. Yeah, it's green. All right. By the same token, we're also going to implement the function called for all. It's sort of diametrically opposed to exist, right? So in fact, maybe let's just copy that, paste it over here. So everywhere where it says exists, we're going to say for all. Oops, that's too much. Going to say for all. Okay. And over here, does not exist. Let's call it not for all. Not for all. Okay, like this. And I'm not sure, but I think we should just flip all the booleans. Yeah, so this should be a true. This should be a false. This should be a false. This should be a true. This should be a true. And this should be a false. I'm accidentally singing over here. All right, so let's go back here. Do the same thing over here. Exists, does not exist. Let's go down over here and call it. This one is not for all, and this one is for all. Okay, now for all needs to be opposed, right? Diametrically opposed. So if exists starts with a false and for all starts with a true, and over here, if there's an or over here, it should be an and over here, right? And I believe that's already everything that we need, and the test should pass. Test don't pass. Oh my God. Okay, so let's see. For all on an empty set should yield false. 461, 467. This is what's happening if you just mindlessly copy stuff. Oh, okay, over here does not exist. That should be not for all. There we go. Okay, only one test failed. 467, 467. Okay, for all size should be false. What? No, that should be true. Why did I flip these? No, that should be true, which means that one should be false. And these ones obviously should be. Why did I not need to flip them? Oh, because I flipped them here. Yeah, that was silly. That was kind of silly what I did. Now what we should do is we're going to go to for all, and because I know how it looks like, I'm just going to do that, and I'm going to press Control D, and what should happen is that it should jump to is subset of. So is subset of is basically saying, does this predicate apply to all the elements, right? So we're just going to say for all over here, call the predicate, and because we have tests, everything is going to be green. I mean, lately we have been a bit sloppy. Well, we've been a bit sloppy with the test, but still we have a lot of tests. We have 55 tests, so I feel comfortable calling for all over here. Okay, the next thing that we're going to do is we're going to implement the toString function, because as of right now we're getting the toString that is coming from function, right? So from function one. So if you take any set, right? Let's just create something over here so that we just see something. So if I create a set of 1 to 3, right? If I print it out, we should see the toString of function, which should just say function. Let me come on, scroll up. So as of right now, this is a toString, right? And this is basically unacceptable. So let's try the first test for toString. toString on an empty set should yield set like this. In fact, maybe we will change it in a second, but let's start with this set. Okay, so so we're gonna do set.empty.string should be like that, right? Should be a string. Okay, and obviously now it's gonna fail because it's actually a function. It's gonna say, hey, function1 was not equal to set with empty parentheses. Okay, so let's go. So toString comes from any. So let's find where we have equals and hash code, and we're gonna add toString over here, right? So it's gonna be final override def toString, just like this, right? So, and it's gonna say if it's empty, then we just want to say set like this. Otherwise, we're gonna throw an exception for now because we don't have a test for that. There we go, it's green. Okay, so now before we write the next test, we need to do a bit of refactoring, because over here, remember every time we're dealing with a non-empty set, we ended up having something like this, and I end up like copy pasting it and copy pasting it and copy pasting it. So what I'm gonna do now is I'm gonna create a very dangerous method, and I'm gonna call it. By the way, why is our fold not at the bottom? I want to have the fold at the bottom. Where's our fold? I sort of forgot to move it in the previous video. Okay, let's just take it out of there. Let's take out the fold and bring it out. Only refactor your code if your tests are still green, because then you can just know right away that everything is still fine. Scalaryform should fix all of this for me. Everything is green. Okay, so I'm gonna go down over here, and I'm gonna create a very dangerous method. In fact, it's not a method. It's gonna be a tuple, which is gonna be deconstructed right away. So because it's so dangerous, I'm gonna make it private and even private to this. So basically, I want to make it shine that it's a dangerous thing. So it's gonna be a lazy val. And it's going to be a deconstructed tuple of element or throw exception, right? So basically, I'm inside of this. I'm going to mimic that, but for these, we're always checking if something is empty. So only if it's not empty. Only if it's not empty. Only then we do this, and this can throw an exception. So what I'm going to have here is going to have element or throw exception, or over here we're going to have other elements or throw exception, right? So the names are very long. I want to make it as inconvenient as possible for people to use, because it throws exceptions, which means that the type system cannot check that, which is not ideal, right? So now over here, what I'm going to do is I'm just going to do that. I'm just going to do that like this over here, right? So copy, paste, okay? And over here now I just need to produce this tuple element, other elements, right? So this should compile. And now, because over here I'm testing it in the fold, I'm testing that it is empty, I can go and just do this. So other elements or throw exception over here, and this element should be this. And because I'm doing that, I don't need to do this. And because I don't need to do this, I also don't need those curly braces. So everything gets smaller, but it's kind of a bit more dangerous, right? So now I'm gonna go through all of these places where I have been copy pasting this code, and I'm gonna use these now. And it has to be a lazy val, right? So it cannot be a def because we're deconstructing stuff here. It cannot be a val because it's gonna explode for empty sets, right? So if I remove this lazy, then all the tests basically going to explode, probably a 55 test. Yeah. So it needs to be a lazy val, and we're just going to go through all of them over here. So for over here, we're just using the elements, so I can just say element or throw exception, and because I'm doing that, I can just remove these, right? And now the code also reads a bit nicer. If it's empty, then it's none. Otherwise, it's the sum of an element or throw an exception. But it's not going to throw an exception because we checked for empty, and we have tests that back us up over there, right? The same thing for singleton over here. So we just need other elements or throw exception, right? So we can go down like this, right? Okay. Now, because this gets so tiny now it's actually more visible how we can reduce this Boolean expression, right? So this entire code is essentially exactly the same thing as just saying it has to be non-empty, right? Because if it's empty, it should be false. So we need to flip this one. It has to be non-empty, and the other elements should be empty, right? This means that there's only one element, right? So it's not empty, but the whole tail is empty, right? It means that there's only one element. So I can comment this out, and the code, the code just gets smaller and nicer and nicer and nicer. All right, so let's just throw this out. And again, very often we're doing like very mechanical transformations here. All right, so let's see. So I'm doing this now, by the way, because for our toString, we're going to end up needing to do this whole destructuring again. So let's see where else. Are we done? Oh yeah. So I guess that was the only few cases where we actually need that. All right, but that's good. That's good enough. How many lines of code do we have now? 159. Okay, it's fine. Okay, sorry for scrolling up and down all the time. Okay, so we're now over here. So now let's add the other toString tests over here. Let's go here and we're going to say toString on a set with one element should yield set of one element, right? Like this. Okay. Now I'm doing the toString implementation that is very similar to what is happening in the Scala collections library. In fact, I'm thinking that we should change it. You know what? We should change it. Just like that. So instead of this, I want to have, you know, like in math, you know, these curly things. Okay, like that. So let's just return curly things, curly brackets over here, right? Okay, so now let's write this test. So in this case, it should not do this. It should just do that. Curly cursor's in the way. One element over here, right? Okay, so let's write this test, and we're just going to have an element. It's just going to be a random string, right? So we're going to create a set of this element, and toString should be, right? It's going to be string interpolation with curly braces. And over here, we're going to have dollar element, right? Like this. Now, this obviously fails, and we're actually, you know, the code that we're going to write is actually going to implement the toString completely instead of, you know, just for this one case. Okay, so what we're going to do is we're going to have curly braces over here, right? So what we will end up having is something like this. We're going to end up having a string interpolation here, right? We're basically going to open the brace and we're going to close the brace, right? And over here in the middle, we're going to have the element of throw exception like this, right? And then we're going to have a dollar here, and we're going to have other elements split by comma space. Now, because I'm getting bad syntax highlighting here, I'm going to have braces here, and I'm also going to have braces here like this, right? Actually, it becomes kind of less readable. Anyhow, let's see what we're gonna have. So this is actually the final implementation. In fact, I really don't like it. Let's not use string interpolation, just for readability. So what I'm gonna do is I'm gonna do this. I'm gonna say plus. I'm gonna say element of throw exception plus other elements split by comma space plus this, right? So I believe that this is a bit nicer. It might be a bit less efficient because we're rebuilding the entire string, but still I believe this is fine. So now, what is other elements split by commas? This is a fold, right? So if we have this other element split by comma space, then we're just going to take the other elements or throw exception, right? And we're going to fold over them. We're going to start with an empty set. And over here, we're going to have, as always, our ACC and current, right? Our accumulation and current. And what we're going to do is we're going to use string interpolation in this case. We're just going to say ACC, comma space, current, right? This is what we should be doing, right? We should have the other elements split by comma space. So we have the other elements, we're splitting them by comma space, right? So this should already be enough. There we go. Let's just add yet another test, and then we should be done. Okay, so let's have another test, and we're going to say toString on the set with two elements should contain the curly braces, both elements, two parens, and one comma. In fact, let's also say over here should contain two braces. Okay, so let's see, because in my preparation I actually ended up, I actually left it the same way as it's done in Scala collections, right? So it's gonna look like this, right? Actually with spaces like that, but now I'm changing it to looking like in math over this, right? Like that. Actually, it's not like that. It's like that. Do you want that or do you want that? What's better? Now we want that. It's fine. We want that. Yeah, that's fine. All right, so this is what we want. So let's see how much of my test I need to change. Okay, so we're gonna have first, which is a random string. We're gonna have a second, which is a random string. And we should also make sure that first should not be second, just to be safe. So we're gonna have our set was first and was the second. And now we're gonna have the actual result. The actual is just gonna be set to string, right? Okay, so now we're gonna say, okay, so actual should include first. So include is a function that comes from a Scala test, right? And also it should include second. Should include second. Okay. Now the next one is going to be actual, and these ones are going to be very tricky. So because we cannot rely on the order, even though we know the implementation, we should never rely on the implementation. We don't really know the order. We should just make sure that the things that we're expecting in there, that they're appearing the correct number of times, right? So what we can do is we can say, okay, count how many times we have the opening curly brace, right? And how many times should that be? It should be one. Should be one. In fact, let's just run this. Let's run this. Okay, so we should have one of these. Then in the end, we should have one of these, right? And I'm sort of gonna write, some code in between. Maybe I should write this as well over here. So I'm gonna do sort of like this, so that it's like sort of the same order. Even though I technically don't want to imply that sets have order. Okay, so what should happen here? So here should be a comma. Let's do actual dot count commas, right? And it should be in this case it should be one, right? It should be 1 comma, yeah, 1 comma 2. So everything should be 1, right? Okay, so and now let's just add another one that contains 2 commas, right? So it's going to be exactly the same code, this exactly the same test. Add it over here, and let's just say 2 commas. Okay, 2 commas, right? So for this we need a third element, so we're gonna have third equals random string, right? So first should not be second, and second should not be third, and therefore first is not going to be third. And what we're going to do here, everything is still the same. Over here we have the third as well. Okay, so we still have 1 here. Okay, so we just need 2 commas, and yeah, I guess we're going to add this test over here, third, right? Yeah, it's sort of like having an order. Let's see. Should not be not found value third. Did I mistype it? There we go. Third like this. All right, okay, all tests are passing, so we have our fancy toString over here. In fact, just for fun, actually see it, because even though we have tests, let's actually print it out. So let's go here and just print out the set. Print line set. We're visual animals, so let's have proof. That's how it looks like. So these are random strings. Now I'm starting to think that maybe it should contain the space. It doesn't really matter. We could add spaces here. Why not? Let's add the spaces over here. Let's see if it actually breaks some of our tests. Let's remove this print line. We don't need the print line, and it's probably gonna break the empty one. No, it's breaking the first one. So the first one is over here. That one. All right. So the very last thing that we're going to do today is we're going to implement tests for equality. Let me find the test for hash code, because remember we just added it because we sort of had it for free, because equality on sets is very well defined. If they're subsets of each other, then they're equal. Okay, let me just search for hash code. Hash code. I don't actually need that. There we go. Okay, so these are the tests for hash code. And what we're going to do is we're going to just add a bunch of tests for equals, because equality has to follow some very, very strict relational laws. It's going to be a lot of typing though, and all of them are going to be green, unfortunately. Unfortunately, in the sense of that, usually you should write a test that is red first. So the first one is that equals should be reflexive, which means that if A is equal to B, then B should also be equal to A. So we're going to have a help function over here. It's going to be called reflexive, and we can give it anything we want, right? And what it will do is it will just go here and say, it's going to say X should be X, and also it's going to do X hash code should be X dot hash code. Now technically it's not necessary, right? But you know, better than nothing. And it doesn't really matter what it returns, because Scala test works in such a way that in order for a test to fail, we should just need to throw an exception, right? So we're gonna go reflexive of set.empty, and I'm gonna occasionally just save the file so that you know, the tests are rerunning. Okay, so we're gonna have reflexive of set of 1 and of set of 1 and 2 and of set of 2 and 1, even though it's not really necessary because the reflexive thing is gonna, you know, swap them for us. All right, so the next one is going to be asymmetric. Oh, in fact, I explained reflexive wrong. Reflexive means that it should be equal to itself, right? So x should be x, and asymmetric is actually the one that I, you know, the way I explained reflexive is actually I explained asymmetric, right? So equals should be symmetric. Why did I keep saying asymmetric? What's wrong with me? All right, so we're gonna have symmetric, which is gonna be the same helper function. So we're gonna have x any, and we're gonna have y any, right? Y any. All right, so over here we're gonna have x should be y, x should be y, and y should be x. Y should be x. Remember, if one of them is wrong, then the exception is going to be thrown and the test is going to fail, right? And let's do the same thing for the hash code. X.hashcode should be y.hashcode. And let's flip that. This is going to be y, and this is going to be x, right? And let's see if it compiles. It should. There we go. All right, so our test for symmetric, and we're going to have plenty of them. So we're going to have symmetric of 2 empty sets. And we're going to have symmetric of set of 1, and over here set of 1, like that, and we're gonna have a 1 and 2 over here, and 1 and 2 over here. Gonna have 1 and 2 and 2 and 1. Not all of these tests are necessary. I just want to make it like a bit more more visible. In fact, the next ones I'm just gonna copy because I really don't want to waste your time. So I'm gonna copy these and I'm gonna paste them over here. These are basically like all the permutations of, so the left one is always 1 2 3, and this one is all the permutations. So 1 2 3, 1 3 2, 2 1 3, 2 3 1, 3 1 2, 3 2 1, right? So this is the symmetry, and all of these should be true. And the last one is going to be transitivity, which means if A is equal to B and B is equal to C, then A should also be equal to C. And if you're sort of not convinced that this is not always true, so if you take classmates, for example, so if I'm classmate with Bob and Bob is a classmate with Alice and I'm classmate with Alice, but if I'm a friend with Bob and Bob is friend with Alice, it doesn't always mean that I'm a friend of Alice, right? So it's not, transitivity is not given for free. All right, so let's write it over here, test. Let me scroll down actually a little bit. Okay, it's going to be called equals should be transitive, like this. We're sort of doing like a almost like a similar thing that Scala check would be doing with these helpers. They sort of generate a test for us, right? So because it does like both ways. And the same thing for transitive. So for transitive, we need a bigger boat. So we need x, y, and z. X, y, z, like this. It creates a unit. So x should be y. Y should be z. X should be z, like this. And the same thing with hash codes. X hashcode should be y dot hashcode, and y dot hashcode should be z dot hashcode. Let me scroll down a little bit. And x dot hashcode should be z dot hashcode, and this should have been an x over here. See if it compiles. It should. Okay, so we don't need actually many tests for this. So we're just going to go transitive set dot empty. Set.empty, set.empty, right? And the other one is going to be set of 1 2 3, set of 3 to 1. I was just like at this point, like when I was writing these tests, I was just flipping them however I wanted. 2 1 3, right? All the same thing. All of these sets should be equal to each other. Right? Okay, and let's also add a few tests that should actually not equal, right? So I'm just going to say these should not be equal, right? So we're implementing the test for equality, and we already have the equality. But one important thing about equality is subtypes, right? Subtype polymorphism, right? So let's see what we have here. So we have set of 1 should not be set of 2, right? So, you know, there's nothing fancy there. Let's flip that as well. Set of 2 should not be set of 1, okay? Whoops, set of, what's happening? Set of 1, like this, okay? So the next set of group is going to be set of 1 should not be 1. And over here, if we had the, how's this called, compile plugin called from Artima, Artima SuperSafe, right? Which also comes from the same people who created Scala tests, Bill Venners mostly. If we had this plugin installed and it has a community edition, which it would check this case at compile time, and this would not compile, right? But we don't have this plugin because I still want to write this test. I want it to compile and I want it to fail, okay? Because in the production code we're not going to have this plugin, and also like the users of our library, they're probably not going to have this plugin, right? So I prefer to do it because I didn't figure out a way to turn this off. Okay, so I ended up not using the plugin at all. Okay, so set of 1 should not be 1. So in the perfect world, this should not compile, but you know, at least we have a test for that. And the reverse thing, 1 should not be, should be not. 1 should not be set of 1 over here, right? And we're gonna go over here. I'm gonna say set of 1 equals 1 should be false, right? Going straight for equality. And we're going to go for this one also. 1 equals set of 1. And notice what the Scala compiler will do. The Scala compiler will actually, it should generate a warning. In this case, because it knows, in this case, it knows comparing values of types int and homegrown collection set of int using double equals symbol will always yield false, right? So I'm just going to comment this out because I don't want this warning over there. But you know, at least we've seen that the test is green. Okay. All right. So the others is set of 1. We're almost done here. No worries. Should not be set of 1 as a string, which happens like so many times. Okay. That you accidentally write something like this, which is one of the reasons why the SuperSafe Artima plugin exists. So this should not be a set of 1, right? So basically completely flipped. The next group is going to be set of 1, and essentially the same thing as over there. It was equality, right? This one should be false, and on this one, sorry, it should be like that, and this one should be like that. Equals set of 1 should be false. And let's see. Now, isn't this beautiful? In this case, we actually don't even get a warning, right? So, the compiler is trying to help you out, but it just doesn't always can. Beautiful English today. It doesn't always can. Jesus. All right. So let's add also these ones. Set of 1 should not be set of 1, 2. And then let's reverse it as well. 1, 2. Again, as I already mentioned, like most of these tests are actually not necessary, but I want to make it like a bit more visual. Okay, because we're testing here multiple elements. And the last one that we're going to have is we're going to flip that. So we're going to test the order. Should not be set of to 1. And over here, set of to 1 should not be set of 1, like this. All right, and I believe that these this is all the tasks that we have for today. Let me look real quick if we need to improve something, and after that we're pretty much done for this video. Just really quickly scroll down. It's fine. All of it is fine. Yeah, I don't see anything suspicious over here. Real quick. By the way, look at how many tests we have. So by now we have 600 lines here and only 160 lines over here, right? So somehow, the code on the right, the production code tends to get smaller and smaller, and the tests they tend to get bigger and bigger, longer. All right, so I believe we're done with this video. As always, Let's commit that stuff. Let me press Control L. Okay, so we can do git status as always, git add, git commit everything. So we're gonna call it video 6, and I'm gonna call it generalizing sets, right? And don't confuse this with generics. It has nothing to do with that. It just I just used this, you know. So general and generic is not the same thing, right? So we just make them a little bit more general because we have, for example, filter instead of just only intersect, and you know we made sure that you know the functions like exists and for all and so on, that you know the intersection and so on, that they take a function as an argument, and they're not constrained to only get the set, which is why you know we made sets a little bit more general. But it has nothing to do with generics, and it has nothing to do with parametric polymorphism. In fact, in this case, it actually has more to do with the subtype polymorphism, right? Because we said a set is a function. All right, so let's do that. Let's push that. My neighbors are playing some music kind of loud. All right, so now it's pushed. Now let's go to our commits, refresh, and it should be 6, video 6, generalizing sets. And let's see, we mostly added some stuff, refactored a little bit. Yeah, so you gotta love like you know tools like GitHub where you see exactly what changed. So you know, so you can look at it at your own pace. We added a bunch of tests, you know. Yeah, and that's pretty much it for this video. Like this video if you did by clicking the like button, subscribe if you want to improve the developer inside you, and most importantly, take care.